Okay, hello and welcome to our 7th grade lesson 3-1, 2, and 5. We're doing 3 lessons today. We are doing 3 lessons because we've seen a lot of this stuff before in our previous years, so it's not anything too new for us. So today we're going to be talking about fractions, percents, and decimals, and specifically decimals that are repeating and terminating. What are those two different kinds of decimals? Now you can see I have my anticipatory set kind of set up right here. And all we're going to really talk about today is one of my favorite things to eat, dip. Any kind of dip. Guacamole is always one of my favorite dips to use, especially since it's kind of football season. It's always good to have some dip around. In my guacamole, I always like to have a little bits of tomato. You know what? Also throw a few little onions in there. Ah, that sounds delicious. Then, of course, you need your delicious corn chip to dip and get some of that dip. Now, this is my favorite thing that stuck with me all the way from my 7th grade year. That's very helpful. The thing we got to remember is dip. All right. And that's it. That's our anticipatory set right now. Just remember how delicious and nutritious and awesome dip is. Maybe not nutritious, but delicious. Okay, let's go ahead and get started. We have a couple language of the discipline to talk about today. The first one is, oh, I'm so sorry. I almost skipped over our standard. Let's go ahead and write our standard. And we actually have 2 standards. I almost totally missed that. Okay, standard number 1 is 7.NS.2.b. 7.NS.2.b. And it says, understand that integers can be divided provided that the divisor is not 0 and every quotient of integers, and of course, meaning with non-zero divisors, is a rational number. Every quotient of 2 integers is a rational number. And finally, if P and Q are integers, then negative P divided by Q, so the negative sign on the outside of the parentheses of the problem, is the same thing as saying negative P divided by Q. So now the negative is just on the P, and is also equal to P divided by negative Q, just like that. It's important to remember that those are the same. All right, our second standard is 7.NS.2.d. So we have 2b and 2d. And this one says to convert a rational number to a decimal using long division. And then we can put a semicolon. Know that the decimal form of a rational number terminates in zeros or eventually repeats. So terminates or repeats. Repeating, terminating. All right. Kind of see where this is headed. Okay, so those are our two standards. Now let's get into our input and our language of the discipline. All right, so we have three languages of discipline we're going to talk about today. The first one is ratio. Is a ratio. I know you've heard that word before. And a ratio is a relationship in which for every x units of one quantity, there are y units of another. Okay? My favorite way to show a ratio, again, I'm not a good artist. Everyone should know that now. But I love Star Wars. There's going to be a new movie coming out. Very excited. So, because it fits into it nicely, here are some X-wings. Okay, and we'll do one more. And our X-wings are going to be our X value, obviously, get it? And our Y value are going to be, oh, these are a little harder to draw. Our Y wings. Oh, those. All right, I know they're terrible. I shouldn't have drawn Y wings. Oh, there's a better one. Oh, much better. Okay, so a ratio is a relationship in which for every x units of one quantity, there are y units of another. Now, if the x-wings are our x value and the y-wings are our y value, a ratio simply says that there are x, and then this is how we show it, to y. How many x are there to y? So there are 4 x-wings to every 3 y-wings. So if we had more and more of these, this ratio would be the same no matter what. If we had another group of fighters fly in, we could say that it was going to be 8 to 6, right? 8 for every 6, but we simplify that down, and 4 to every 3 y-wings. So that's just a ratio. It basically tells you what the relationship is. Okay? And you can always show a rate, or you can show a ratio by putting it as a fraction. So 4/3, 4 over 3, 4 of the x-wings over 3 y-wings. Okay? So that's just a ratio. And you've probably seen that before, so it's a good thing to remember. You will be needing that, especially on our guided practice today. Okay, and our next one is going to be a repeating decimal. A repeating decimal. And a repeating decimal is a decimal expansion. A decimal expansion that repeats. Interesting. A repeating decimal is a decimal expansion that repeats. Interesting. That repeats the same non-zero digit or block of digits. without end. All right. So repeating decimal is a decimal expansion that repeats the same non-zero digit or block of digits without end. So we're going to use one of our icons here, which is our pattern icon, because we're going to be able to notice a pattern. Remember, this icon is how we can recognize patterns. It helps us know when we're looking at a pattern. So let's say you have a decimal like 0.2222222222222, and it just keeps going on and on and on and on and on and on forever. You really don't want to sit and write 0.22222 on and on and on and on forever before you can go on to your next thing. Each question in math would take your entire lifetime and you still wouldn't be done. So instead, we just write this as 0.2, and then we put a line over the top. So we call this 0.2 vinculum. And what that means is that that digit will repeat over and over and over and over and over and over again forever. Now that does not equal this. 0.2 vinculum does not equal 0.2. They are not the same number. Okay, so let's do a little example so we can sort of see what we mean here, how it happens like this. The example I'm going to use is 1/3. And if you can see 1/3, you know that that fraction bar is division. It's the same thing as saying 3 being divided into 1. And then we all know how to use long division, although here it looks kind of short division. Our long division is 3 goes into 1 how many times? 0. 0 times 3 gives us 0. Subtract it, get 1. Oh, there's no more digits, so we have to put a decimal. We have to put a 0 and drop it. 3 goes into 10 3 times. 3 times 3 is 9. Subtract, we get 1. We add another 0, drop it. Look at that, it's a 10 again. 3 goes into 10 3 times. 3 times 3 is 9. We subtract and get 1 again. I'm out of paper, but you can imagine it's going to continue every single time. It's going to be 1. We're going to add a 0 to it. 3 goes into 10 3 times, and it equals 9, and we get 1 again. And every single time you're going to have to divide 3 into 10. And every single time you divide 3 into 10, you're going to get 3. And it's going to go on and on and on and on and on forever. So instead of doing long division until you die and still not being at the end of your problem, we realize a pattern. We see a pattern, and we understand that we can instead write 1/3 as 0.3 vinculum. That digit will repeat forever. Now, what if you had a mixed number? What if instead it was 2 1/3? Well, that's the easy thing about this. 2 1/3 is just going to equal, you leave the whole number the same, 0.3 vinculum. It goes on and on and on and on and on forever. So it's actually pretty easy when you get a repeating, or when you're trying to make a decimal out of a fraction, it's a mixed number. You don't have to worry about it. It stays the same. Okay, so that is our repeating decimal. Let's move on to our last language of discipline for today. And I'm going to have to actually switch out, get a new piece of paper. And yes, I know, I don't know what happened when I tried to rip out these pieces of paper. It's very frustrating to me. I hate when that happens. All right, let's go ahead and move on. Our next language of the discipline is a terminating decimal. A terminating decimal. And if we just did a repeating decimal, terminating decimal is going to be the opposite. So a terminating decimal is a decimal expression that ends in zeros. It ends in zeros. So we just saw one that was a repeating decimal that goes on and on and on and on forever. Let's take a look at 3/4. 3/4. What would 3/4 become? Well, This is the same thing as saying 4 divided into 3. 4 goes into 3 0 times. 0 times 4 is 0. We subtract and get 3. We just continue to do our long division. We drop a 0. We put a decimal point. So now we have 4 goes into 30. 4 goes into 30 7 times. 7 times 4 gives us 28. Come on, focus. There we go. Gives us 28. We subtract and get 2. We have to drop another 0. 4 goes into 20 5 times. 5 times 4 gives us 20. Subtract and get 0. Now look at what happens next. If we want to keep going, we drop a 0. 4 goes into 0. 0 times 4 is 0. Subtract and get 0. We add another 0. We can continue doing long division as long as we want, but the answer will be the same every time because there's nothing left to divide, and it'll just go zeros forever. Now we know we don't need to write those zeros, so this is what we call a terminating decimal. 3 fourths equals 0.75, and we don't have to put those zeros. So this is a terminating decimal, Now, this is not the same thing as what if you saw this, 0.75 with a line over it. That is not the same, right? Because this, now we're looking at not that we are repeating a non-zero digit, but a block of digits. So if you see the line over 2 numbers, that's going to equal 0.75, 75, 75, 75, 75, and again, it's a pattern. So that is why this number and this number are not the same. Okay, so that is our terminating and our repeating decimals. So hopefully we understand that. That shouldn't be too difficult. We've seen things like this before. You know how to do long division. You just need to know which one is a terminating digit or a terminating decimal and which one is a repeating decimal. And it's all about that right there. If there's a line or if there's no line. Okay, so let's move into what we're doing today, which is we need to know how to alternate between different types of numbers. Any rational number can be seen in several ways. So we're going to go ahead and deal with some rational numbers. And let's go ahead and put our flower over here on the side too. There we go. Rational numbers. Now, there's 3 main ways we can see a rational number. There's one which is a fraction. There's one which is a decimal. And then there is a percent. And we can write a rational number in any of those 3 ways. So let's start with a fraction. We're going to do a little example problem right here. So we're in 2012. There were the Summer Olympic Games, right? And in those games, the US won 106 medals. They won 46 gold and 106 total medals. So So 46 of the 106 medals were gold. What percent of the U.S. medals were gold? What percent? So what it's asking us to do, it is asking us to take this fraction and make it a percent. Now it's very difficult. There is a way, but it is very difficult to take the fraction and change it directly to a percent. That is why we have this decimal here. It makes it so easy. Instead of jumping all this way, we'll be able to land on this little island right here and then jump over to percent. So the first thing we need to do is we need to take a fraction and we need to make it a decimal. So how do we take a fraction and we make it a decimal? Well, we just did it twice with our terminating and repeating. You take the fraction and you make it division. So now we have 106 divided into 46. Well, We all know that 106 going into 46 is going to have to be 0, which will give us 0. We subtract and get 46. There's no more digits. We have to put a decimal point and add a 0. Now 106 is going into 460, and that's going to be 4. 4 times 106 is going to be 418. We subtract. We need to do a little bit of fancy borrowing there. And now we're going to have 42. Okay, we need to add another 0 and drop it. 106 goes into 420 4 times. Oh, you may be saying, look at that. We may have a repeating decimal. Well, you always need to go a little further, right? And we should probably get our decimal at least to the thousandths place. Right now we're in tenths, hundredths. We got to at least go to the thousandths. And we'll see where it goes from there. Okay, so now 4 times 106 again is 418. We subtract a little bit more fancy that. We're going to have a 2. Okay, so that's a different number. Again, we'll go ahead and put a 0, drop it down. 106 goes into 20. 0 times 106 is 0. We subtract, get 20. Add a 0, drop it down. 106 goes into 200. 1 time. 1 times 106 is going to give us 106. We subtract. We have to do a little bit more fancy borrowing. We're going to get 94. Now, we can continue to go, but we really only need it up to the thousandths, and we're already at the 10,000ths. But we could always keep going, but you'll see right now we don't have a terminating or a repeating. We can't prove it yet. Maybe we'll prove it at some point, but it's going to go on and on and on. But really, we don't need to do that. We're trying to figure out what the percent is. We really only need this number. Because to get a percent, we get to talk about my favorite thing ever, which is dip. Dip is so delicious. Dip stands for decimal. The D stands for decimal. The P stands for percent. And it tells you how to convert a decimal to a percent and a percent to decimal. Now, if you're taking a decimal and you're going to a percent, you're moving the decimal 2 times that way. If you're taking a percent and moving it to a decimal, you're taking the decimal point and you're moving it back 2 times. So let's take a look at how we do that. Our number, so to remind you, dip. So now we have a decimal. Our decimal is 0.440. We only want it to the thousandths, right? Because we're just trying to find the percent. So let's use dip, and let's put our decimal over here and change it to a percent. 440. Dip tells us that we have a decimal, and we need to get to a percent. So that's going to be 1, 2. Take our decimal point, 1, 2. And our new number, our percent, is going to be 44%. Now, it wasn't exact because we didn't do all of this division. So we have to say about 44% of metals were gold. And there we go. We figured it out. Now, there's one thing that we've talked about that I didn't do right here, which is the ratio. So let's look right now. This is our fraction. So what would our ratio be of those metals? It's just the relationship. So to form the ratio, you just look at our fraction and say, for every 46 metals, there were 106, or for every 46 gold metals, can't see that. For every 46 gold metals, there were 106 metals. All right, so now we have gold metals and metals. Now, you can also find other types of ratios with this information. If we have 46 gold metals and we want to write the relationship of gold metals to other metals, not total metals, we would just have to do some simple subtraction. 106 minus 46, get the gold metals out of our total metal count. Okay, so 60 of our 106 metals were silver or bronze. So if we write a relationship, or we write a ratio of gold metals to other metals, it would be like that. this would now be gold medals. This would be silver and bronze medals. So that's how our ratios work. Okay, it's just a relationship between two numbers, and that's why. And you'll see this when you're doing your measuring up. When you're measuring up, when you're doing word relationships, you write it that same way, right? So this is actually cross disciplines here. And if you're doing hot is to cold as smart is to dumb, you're going to be using that same thing, right? Smart, because those are opposites, right? There's still you're talking about a relationship. So the relationship here, the relationship here. Okay, so let's now move on to our modeling. I'm going to use a new piece of paper. And in our modeling, I'm going to go ahead and work through two different methods. Okay, and again, modeling. Okay, in our modeling, we now have all the information we need, how to convert between these different things. So now let's put it into action and find the percentage of a group. Find the percentage of a group. How do we find the percentage of a group? Let's take what we've learned and adjust it and now use it. There are two methods. Remember, there are always more ways in math to solve a problem. You find which way works for you the best. So we have method 1 and we have method 2. Okay, so we're going to do the same problem on both. Method 1, we're going to do 64% of 250 people. 64% of 250 people. All right. Now, one way to solve this is by finding a fraction with a denominator of 250, because that's how many people. Now, the way we start off with this is we start off with our percent. 64%. What does 64% equal? Well, using our Greek and Latin roots, we know that cent would mean 100. So 64% would mean 64 per 100. So it's actually going to be 64 over 100. Now, the first way to do it, and I'm not a huge fan of this way, but this may be a great way for you. Now, this way you use your logic, you sort of use this riddle of how do we get these two numbers, how do we get this fraction to have a denominator of 250? What can we do to the top and bottom to work that out? Well, first step, you can say, all right, well, 100, I want to get to 250. Right now we're at 100. Well, I can divide 100 by 4, and I have to do the same thing to the top, which will then give me a new fraction, an equivalent fraction, which would be 16 over 25. Okay, so now that was my first step. Now look, 25. How do I get 25 to be 250? Well, that's easy. Times 10 times 10. And then you go right here and you say, all right, our new fraction now is 160 over 250. Now we have a denominator of 250. And we're able to say, okay, 64% of 250 people is actually 160 people out of 250 people. Now that's one way. And I will tell you right now, I do not like that way. Because for me, looking at this, trying to plan out, okay, what do I have to do to the bottom to get it to 250? Divide by 4, then multiply by 2. I don't like that so much. I prefer just to do the math and not have to sort of guess and figure things out. So this may be a great way for you to do it. I don't like it so much. That's why I put my little frowny face, but you could have a happy face there. It's up to you. All right. Method 2 is the same thing, 64% of 250 people. And the second method actually gives us an equation. There is an equation to deal with percent, and it is called the percent equation. That makes sense. And what the percent equation is, this is what you do. The part equals the percentage times the whole. Part equals the percentage times the whole. Now we have to decide what is the part, what is the percentage, and what is the whole. What is the total amount of people? 250. What is the percentage? 64%. So what are we looking for? The part. So let's fill in the parts we know. We don't know this, but we do know the percentage, 64%, and we do know the whole amount of people, which is 250 people. Now the only problem here is we can't multiply a percent, but we can change the percent into a decimal using the delicious dip. So if I have 250, here, if it's a decimal, or if it's a percent, I'm here, and I move to this direction. So my new number is going to be, I got a little ahead of myself, my new number is going to be 0.64 times 250. Now I can just do a multiplication problem. 250 times 0.64. Now I remember how to multiply decimals. Hopefully you do too. So I move this decimal out of the way. I have to remember to bring those two places over next. And then I multiply. 4 times 0, 0. 4 times 5, 20. 4 times 2 is 8, plus 2 is 10. I got to draw my placeholder. 6 times 0 is 0. 6 times 5 is 30. 6 times 2 is 12, plus 3 is 15. And a 0, I don't have to do that one because it's going to equal nothing. And then I add 0 and 0, 0, 0, 0, 0, 0, 0, 0. 5 plus 1 is 6, and 1 is there. Then I take my two decimal points and move them back, cross those out, and look at that. I have the same answer. So how many people? 160 people. So both methods work. I prefer this one because I think my mind works a little bit more that way. I like to just see the equation. The equation makes more sense. Now, this might make more sense to you, and you say, oh, I can definitely make that 100 denominator a 250. You just have to make sure you understand it. So it's up to you. Okay, we're going to have just two more quick modeling questions. And the first one, I guess this would actually be number 2 now. Number 2, we're going to take, this will be the last one we do, we're going to take a version, we're going to take 1/8, we're going to take 0.125, and we're going to take 12.5%, and we're going to change them into each of their other forms. So there we go. We're going to take these numbers and we're going to change them into their other forms. So this one is already a fraction, so we need a decimal and we need a percent. So let's take this fraction and let's make it a decimal. Well, the decimal part of that is easy. If you look back at your notes, it'll show you that it is just a division problem. 8 goes into 1 how many times? 8 goes into 1 0 times. 0 times 8, 0 minus gives us 1. We have to put our decimal, drop a 0. 8 goes into 10 1 time, gives us 2. Drop a 0. 8 goes into 20 2 times, 16. Subtract, we get 4. Drop the 0. 8 goes into 40 5 times. Times 5 is 40, and that's going to give us 0. Oh, I went into my other zone there. Oh well. So our answer for what is the decimal form of 1/8 is going to be 0.125, and it's going to terminate. I don't need to put any line over the top because it terminated right there. Everything else is going to be 0. And now the easy part. How do we make it a percent? We use dip. 1, 2. So our answer is going to be 12.5%. Now, as you can see, 0.125 is going to be the same thing here. So for this one, we have a decimal. And we know how to make it a percent because we just did it over here. So I'm going to avoid this part, especially since I wrote into it. Oh, I'm so sorry. But how do we make a decimal a fraction then? Well, we just read the decimal, really. 0.125 is the same thing as saying 125 thousandths because we're in the thousandths place. So you just write it as 125 over 1,000. And then you just simplify. Now, since we know this is the same number, I'm just going to simplify by going divided by 125 divided by 125, and that's going to equal 1/8. And finally, down here, I have it in its percent form already. Now on that one, I want to make it a decimal, and I want to make it a fraction. Okay, so if I have 12.5%, we're going to go ahead and use dip again. I'm starting on the P and moving backwards, so I have to start here and move 2 over. It's going to give me 0.125. Huh, looks familiar. Then, to make it a fraction, 125 thousandths, 125 over 1,000, which we know equals 1/8. So any of those types of numbers are very interchangeable. We just need to make sure that you can easily switch between any of those to solve your problems. All right, our guided practice is going to be just 3-5 guided practice. If you want some work with, repeating and terminating decimals, you can definitely go ahead and do 3-1 and 3-2, or you can look through some of that. I assigned that as well, but you just need to complete 3-5. For independent practice, is going to be front row ed. And you are going to go to 7.NS.2, and you're just going to do D. We've done B. I think we've already done B twice. So you're going to go 7.NS.2.b&d. And that's your work for today. Good luck. Have fun. Go Buffs.